A servo motor is anything but ordinary. Every motor has a purpose, and every motor tells a story. Buyers and maintenance managers are faced with a decision, yet thousands of good motors are destined for the scrap bin each year. Let's change that.
The biggest thing is downtime. So the biggest decision that the buyer or the maintenance manager has to make is, are they going to go with new or are they going to go with a repair? And what we're here to do is give them confidence and go on the repair route. The lead time is significantly shorter. A lot of times motors, brand new from the manufacturer, have a long lead time. Some of them come from overseas. A lot of them are 18 to 20 week lead time. I've seen approximately 6 to 8 months on some manufacturers. No matter what the failure may be, we're taking it from months to days, sometimes even hours.
Our work is quite investigative in nature. It's more than new bearings and seals. Data is the voice of the motor. It tells us what happened and where the investigation should focus. And it all starts with evaluation. What can be reused? What needs to be replaced? What should be repaired? A good evaluation answers these questions. From pulley end to opposite pulley end, every piece is brought into the light.
You open up the motor, that's when you find out the true story and the true history behind that motor. The biggest thing we like to look at Disassembly is contamination, anything that indicates what could have caused that motor to fail.
Contamination is easy to detect, but difficult to remove.
A lot of companies and maintenance buyers that are not familiar with motors, they hear motors, they think that they need oil. Actually, it's complete opposite. We have several different types of cleaning methods to help extract the oil and the contaminants from these components before the motor is reassembled. Every step of the process is a deep clean.
A longer lasting break above spec is possible.
When they're damaged extensively, the pad material will be worn down beyond use, or the plates may be damaged from heat wear. Sometimes it requires new pad fabrication where we have to cut new pad material in our CNC machine. When the fibrous pad gets loaded with oil or grease, it loses all of its torque and stopping capabilities. So when we grind it, we put it in a high temperature oven that will cause the oil to leak out of the pad, and then we'll degrease it in our ultrasonic cleaner back and forth essentially until there's no oil left in the pad and we can get a good surface to start fresh. During a repair, we may start with Blanchard grinding the plates to get them flat and to give it a crosshatch pattern, which will increase the brake torque when it's built. Depending on the application, we may grind the stanchions to only leave a gap of 0.02, and that would be a very tight fit. That's roughly the thickness of a human hair. It's very tight tolerances, but that allows us to get a good release voltage and torque.
The secret lies within the air gap. A very small spacing between the brake pad and the brake plates. The tolerances are tight. There's no room for error. Most repair shops don't have this capability. We're different.
There's all kinds of failures. Environment is one. What kind of conditions is it operating in? You have turn short, phase to phase short, phase to ground, just age. The coil position is the most important thing because of the magnet rotor positions with the feedback. When the rotor's locked up, if the windings are off, the lockup's wrong. So if the lockup's wrong, the alignment's wrong. So it needs to go back the way the manufacturer had it. Most of the servos are class F insulation, which is 155 Celsius. We put back a class H, which is 180 Celsius. So it's a higher temperature class for prolonged life. So after the coils are inserted and the leads are connected, then we'll test it with the surge tester, the megger, the high pot. The surge tester is a comparison test. It puts voltage into the 3-phase and puts it into a waveform, so it compares one over the other to see if there's any differences. And then it'll come back, we'll lace the windings and prep it for dip and bake. When it comes out of the bake oven, we clean it, retest it, and send it to assembly.
It is very critical how the motor goes back together. If the feedback device is installed improperly, it could lead to a failure not only right off the bat, but down the road. Proper tools, which we actually make and manufacture right here in our machine shop in-house, help reassemble that with extreme caution.
So after we've assembled the motor, the first thing we're going to do is do electrical checks on the motor to make sure that the magnet rotor is at the proper strength, make sure the winding is good, that we haven't damaged anything in the process of assembly. The next thing that we would do from there is we would install the feedback. An encoder signal, you definitely want to check your signals on the scope to make sure that they are aligned properly at speed. The alignment makes the motor function properly with the drive system. If it's not aligned properly, you're going to have low torque, your speed is going to be off, or the motor would just fail upon install completely. We'll do a free running test, make sure everything runs properly. A lot of companies will just ship a motor at that point. What we're doing is taking an extra step and putting it on the dyno to make sure the motor will run under load and won't fail when it's put on your machine.
When things go down, we gear up. The unexpected happens. What matters is how you respond. What's your next move? Get a quick, personalized quote. A great rate on industry-leading repairs is just a click away.